Okay, so for this homework assignment, I decided to do 31, 39, and 89. I think all three of those relatively encompass all of the skills that we've looked at for this section. So when I look at this one, I'm going to give you two methods for solving this. The first method, I am going to try to work with getting the bases the same within an equation by setting it equal to x and putting it into exponential form. So if I do that, 2 to the x equals 1 over root 2. So once again, here's our base, here's our exponent, there's the argument of the logarithm, which is equal to the value, so 2 to the x equals 1 over root 2. Now I want to get like bases. Well, the problem is we have a 2 here, and then we have a 2 in the denominator, so we need to flip it. Before we do that, though, it's important to get the radical into exponent form, and a square root as an exponent is 1/2. Now we want to get like bases, so we need to flip the one on the right. When we flip it, we get a negative exponent. The base stays the same, but flips in the numerator. And now we have like bases, so the exponents are equal. If we go back to the beginning, without setting it equal to a variable, let's try flipping this argument, and once again we know this is 1 over 2 to the 1/2 power. I'm going to flip that 2 to the negative 1/2 power, and now we see that we have an exponent in the argument, which means we can bring that down in front. This comes in front here, so I have negative 1/2 log base 2 of 2. Log base 2 of 2, that's asking a question, 2 to what exponent or 2 to what power gives you 2, which would be 1. So now I have negative 1/2 times 1 equals negative 1/2. In both cases, whether you turn in an exponential equation or use a power property, you get negative 1/2 in both cases. Next, we are going to use both methods on this. If I start off with the first one where I set it equal to x, I have 5 to the x equals our argument, which is 5 to the 7th, and lo and behold, we have the bases the same, so the exponents are equal. If we come back to not setting it equal to x and just use our power property rule by moving this down in front, we now have 7 log base 5 of 5, and just like in the last problem, log base 5 of 5 equals 1, so I have 7 times 1, which equals 7. We get the same in both cases. For this one, this is really exactly the same as the others, but we're really getting used to notation. So anytime you see that ln, which we say is natural log, what it really means is log base e of, and then we have e to the 6th. So I'm going to first time set this equal to x. And remember our base right here, our base, it's not written there, it really is right here. Our base is e, so e to the exponent of x equals our argument, which is e to the 6th, and then we set our exponents equal, so we have x equals 6. If we go about it the other way, where we use our power property, we bring this down in front, we have 6 times natural log e, and that natural log e means e to what power gives us e. Just, again, if we put it in parentheses here, meaning imagine that's there. It's not part of the problem. It's a different way of writing it. But anytime that base and argument are equal, that logarithm equals 1, because e to the first gives us e. So natural log e equals 1. Again, we have 6 times 1 is 6.